Hey mathematicians, here are your notes 1.2 where we're going to be talking about fraction computation. So the goal for today is to be able to compute and solve problems that involve fractions. And I know that fractions can be our nemesis. They seem really overwhelming. Sometimes we want to use decimals because we think it's easier. But ultimately, fractions are more accurate most of the time. And once you do see the patterns that are involved with working with them, they can be a lot less terrifying. So, let's jump into it. Adding fractions. When we have fractions with like denominators, as you see here, 1 over 6 plus 4 over 6. These both have a denominator of 6. This makes it really easy because the only step that we need to take in order to add these is add the numerators. And I'm going to shorthand here. Add the numerators, and then implied there is to leave the denominators alone. So leave the denominators alone. Again, shorthanding. So when I add the numerators, I get 1 plus 4 to be 5, and I leave that denominator alone. Pretty simple. However, when we have problems with unlike denominators, it takes a few more steps. So in order to complete a problem like this, where we have 1/8 plus 1/5, we need to start by finding a common denominator. Find a common denominator. And what this means is we need to find a number that both 8 and 5 multiply to and have in common. So in this case, 8 and 5, the lowest common multiple of those, the lowest common multiple of 8 and 5 in my mind is going to be 40. So I'm going to change 1/8 to have a denominator of 40, and I'm going to change 1/5 to have a denominator of 40. Because once they have the same denominator, we're going to use the same steps as we did up here. So once we have found that common denominator through finding the least common multiple, we need to multiply each fraction to get that LCM. So to go from 8 to 40, I had to multiply by 5. So I'm going to do the same thing to the numerator. 8 times 5 is 40. 1 times 5 is 5. That's pretty simple. Same thing over here. When I went from 5 to 40, I multiplied by 8. So I have to do the same thing to the numerator. Now I haven't actually changed the problem at all, because if I reduce these two fractions, I'm going to get 1/8 and 1/5. So all I've really done is make them look a little different. But in making them look a little bit different, I allow myself to treat this problem now as if it was one with like denominators. Again, just as we did before, we're going to add the numerator and leave the denominator alone. 5 plus 8 is 13, and we leave the denominator, so we get 40. Now, most of the time, I would ask you to reduce your answer. We want the most simple thing to look at. The same way that we don't really want to do problems with 5 over 40 and 8 over 40, we want to work with 1/8 and 1/5. We don't really want to work with big numbers like 13 and 40. In this case, it can't be reduced, so this is your final answer. I've given you some problems here where you can go ahead and try those out. Again, just as I showed you in the last video, if you need to simplify these a little bit first by determining what kind of problem they are, whether they have like denominators or unlike, that's okay. This one has a 2 and a 5, so these are unlike denominators. So my first step, and if you need to write the steps, you can do that too, is find that common denominator. Find the least common multiple of both. So 2, 4, 6, 8, 10, 5, 10, 15, 20. The first number I heard them have in common would be that 10. So I'm going to turn each of them into a fraction where 10 is the denominator. So I'm actually going to just pull this number down here, pull this number down here. over 10 over 10. I'm going to just bring that addition sign down as well. To get from 2 to 10, I have to multiply by 5. So I'm going to multiply the numerator by 5. 1 times 5 is 5. I double check myself. 5 over 10 is the same thing as 1/2. And now I'm going to jump over to that second fraction. Notice, this one I'm not immediately going to multiply by 5 just like I did in the first one because I have to treat that fraction a little bit differently. In this case, to go from 5 to 10, I have to multiply by 2. So to go from 3 to the numerator, I have to also multiply by 2. 3 times 2 is 6. I now have two fractions with a common denominator, or with a like denominator. So now, just as I did in my other problem, I'm going to add those numerators. 5 plus 6 is 11. Leave the denominators alone. That's 10. And my final answer is 11 over 10. Now I have to think about that. I need to make sure that I don't have any reducing that can occur. In this case, 11 over 10 is an improper fraction, so we could turn it into a mixed number. I'm not going to at this point. We could maybe see that in another video, but right now I'm going to leave this as my answer. And because I like to be really clear, I always box my answer to indicate that I am done with the problem. Let's see another one. This one also has those unlike denominators, so my first step is finding that least common multiple. If I do this, I go 7, 14, 21, 28, 35, and so on and so forth. And if you need to list those out, you can do that. With 5, I go 5, 10, 15, 20, 25, 30, 35. I hear it at that 35. So in this case, the lowest or least common multiple is going to be 7 times 5, which is 35. So when I bring those numbers down and turn 6/7 into a different fraction, my least common multiple becomes my denominator for both fractions. How did I get from 7 to 35? Well, I multiplied by 5, so I have to do the same thing to the top. 6 times 5 is 30. If I reduce that, I do get 6/7. Now I'm going to jump over here to 3/5. To get from 5 to 35, I had to multiply by 7, so I have to do the same thing to the numerator. 3 times 7 is 21. And then, of course, bring down that addition sign. Now that they have like denominators, 30 plus 21 is 51. 35 gets left alone. Again, improper fraction could potentially change to a mixed number, but I'm not going to do anything with that. Just box it. Alright, if you've been following along so far, quick pause that video, do the next one, and see if you're right. This is an easy enough problem that you can check it all on your own. Alright, hopefully you paused that video and tried this one. Some of you might have immediately looked at this and said, hey, 5/10 is the same thing as 1/2. 1/2 plus 1/2 is 1, so I know that one. I don't have to do the math, Miss Burry. Hey, that's okay. I want to show you why this method works. When we have 5/10 and 1/2, my least common multiple is going to be 10. I don't necessarily have to change denominators. Sometimes I only have to change 1. Those are the nice problems. And if I bring those down here, 5/10 stays the same. To get from 2 to a denominator of 10, I have to multiply by 5. I do the same thing to the numerator. 5 times 1 is 5. Bring the addition sign down. 5 plus 5 is 10. Leave the denominator. 10 divided by 10 is 1. So yes, you could have immediately seen that this is 1 and not gone through all that work, but this does in fact prove that the method works. Alright, let's jump down to subtracting fractions. It's very much the same as adding. So, with like denominators, we're still just going to subtract the numerator, still shorthanding here, subtract the numerator while leave the denominator. I always write that little note so I know not to mess with it. So in this case, 4/5 minus 2/5, I'm going to subtract the numerator. 4 minus 2 is 2. Leave the denominator alone, 5. Reduce, usually. In this case, I can't, so that is my final answer. You're going to notice me writing fractions two different ways. Sometimes I'll put it directly over the denominator. Sometimes I'll do the slash. Both are correct. I have no preference on which one you use because you see me using both of them. So you can use both of them as long as you make it obvious. All right, with unlike denominators, same thing. We still have to find a common denominator or find the LCM, least common multiple. Once we find the least common multiple, again, we're going to multiply each fraction, or we're going to rewrite the fractions with a common denominator. You can write this out if you prefer, just W slashes with CD is common denominator. And then, of course, once we have subtracted and simplified, I guess I'll write that subtract and reduce. So in this case, these do not have a common denominator. I'm going to find that LCM, the lowest common multiple of 5 and 3, 5, 10, 15, 20, 3, 6, 9, 12, 15. The first number I heard they have in common was 15. So when I rewrite them with that common denominator, I'm going to write them both as being divided by 15. I can bring that subtraction sign down just because I have time. To get from 5 to 15, I multiply by 3. So I do the same thing to the numerator. 3 times 3 is 9. Same thing over here. 3 to 15 is a multiplication by 5. Multiply the numerator by 5. We get 9/15 minus 5/15. We have already rewritten them, so now we're going to subtract and reduce. 9 minus 5 is 4. Leave that denominator alone, and we have 4 divided by 15. We can't reduce it, so we're good to go. All right, I want you to try those next three on your own. Pause the video here. Once you've given them an attempt, come on back, we'll do them together. All right. Hopefully you were able to pause the video. This one starts off 3/4 minus 10/16. I'm going to start skipping a few of those steps. I think we're ready for that. I notice right away 4 and 16, they're unlike denominators. However, because 16 is a multiple of 4, I only really have to change this fraction to be one that is divided by 16, because then I can leave the second fraction alone. I could also reduce this fraction and try something that way, but this is the fastest method in my mind. 4 to 16 becomes 12 on top. 12 minus 10 is 2. Leave the denominator. This one I do see can be easily reduced, so I'm going to reduce it to 1/8 and box my answer. Same thing here, LCM is 15. Write them both being over 15. 5, 3, 5 minus 3 is 2. Over 15. Can't reduce, so I box my answer. All right, 1/3 minus 4/5. That is another 15th. I'm actually going to skip that problem. Go ahead and try that on your own, but we're going to jump to the back. Multiplying and dividing fractions. Let's start off with multiplying. The nice thing about multiplying fractions is that it does not matter if we have like or unlike denominators because the method stays the same regardless. We're going to multiply the numerator, multiply numerators straight across, and then we're going to multiply the denominators straight across. And yes, it is really that easy. So in order to get my final fraction here, I'm going to multiply the numerators. 2 times 5 is 10. 7 times 3 is 21. And then reduce if necessary. In this case, I don't have to. You can go ahead and try the next ones or follow along with me. 3 times 1 is 3. 4 times 8 is 32. Took me a minute there. This is why I said in that last video, we gotta know the multiplication, because right now we're only working with positive numbers. However, if I start throwing negative fractions in there, all of these rules apply, but so do all the negative rules that we learned yesterday. So let's keep going. 7 times 1 is 7. 19 times 3, that one I'm actually gonna have to do in my head. That one would be 60 minus 3 would be 57. Can't reduce. I usually would box these answers because I don't have any work. I'm not going to. 3 times 7 is 21. 10 times 6 is 60. I think those are both divisible by 3, so this becomes 7 over 20. And that I am going to box. Dividing fractions. You're like, oh yeah, I just divide the numerator by the numerator and denominator by the denominator, except that's going to get really tricky because then you've got 6 divided by 9, which doesn't come out nice, and 10 divided by 8, and that doesn't come out nice. And that was a great thought. Here's the trick. We actually have to adjust our fractions slightly before we're able to divide them. And the phrase you're going to hear me say all the time is something called keep, change, flip. What this means is we're going to keep the first fraction. We're going to change the sign, and then we're going to flip the second fraction. Now, why are we going to do this? Well, because it turns division into multiplication, which, as you saw above, is actually pretty simple. So let's see what that looks like with this problem. If I use my keep, change, flip, I keep the first, I change the sign from division to multiplication, and then I'm going to flip my second fraction, because 9 divided by 8 becomes 8 divided by 9. Now, this is just a multiplication problem where I can multiply the numerators and the denominators. So 6 times 8, this is one that's always given me a problem. I believe it's 48, if I'm not mistaken. And then, of course, 10 times 9 is 90. I can reduce this one. Off the top of my head, this would actually be 2/3 and 8/10, which would be, I'm actually going to leave that one to you. I could sit here and do it. It's just going to take me a minute because it'd be 24 over 45. And then divide both of those by, I think they're both divisible by 3. Yeah, so it'd be 8 over 15. And you can't simplify any further? There you go. 8 over 15. Took me a minute, but that's okay. Even math teachers are a little bit slow with certain problems sometimes. 48 has always been one of those numbers I didn't like. Anyway, let's keep going with that. 1/4 divided by 1/3. Let's use that keep, change, flip method again of keep the first, change the sign, flip the second, and then multiply. 3 over 4. I love this method because even though this looks like a hard problem, when you remember that keep, change, flip, it's actually pretty simple. It doesn't take that much to actually adjust the problem. I noticed here, and maybe you noticed too, that you've got 2 7s in opposing corners. The really awesome thing is we could reduce this to 1, and I'm going to show you why that's really cool in a minute. If I just do the problem through, I'm going to get 14 over 35, but those are both divisible by 7. Notice we've got 2 7s involved. What that means is if we divide a 7 out of both of them, we're going to get 2 over 5, which is what we would have got if we had reduced 7 divided by 7 to be a 1 on top. 1 over 5, 2 over 1, it would have ended up as 2 divided by 5. All right, last one here. 4 divided by 14. Keep, change, flip. This is another one. You can notice this is one that is reducible. You could reduce right away and go to 2/7 because you can either reduce now or at the end of the problem. Either way, you're gonna get the same answer. 14 times 7 is a tricky one. That's why I'm gonna jump down here and say 7 times 7 is a little bit easier. If I multiply that one by 2, I get 198. Yes. So you can see if I reduced from here to here, I can either reduce at the end of the problem or at the beginning of the problem. If you'd like to see more about why this method actually works, come and talk to me. I'm not going to cover that in this video. I just want you to know the keep, change, flip method. Let me know if you have any questions.